One important vector operation is divergence, or in other words, the dot product of gradient dot product, or we say del dot f. This is more straightforward than the curl, which is a more complicated function. In this case, we take the x partial derivative of the x component of the x part of the vector, the y component, the y partial derivative of the y component, and the z partial derivative of the z component. As an example, here are two functions that I've taken the divergence of. So first we take the partial x derivative of the y part, which we have right here, and the partial y derivative of the y part. In this case, these are both 0, and so we get a sum total of 0. Another example, both from chapter 20, is we take the divergence of minus x I hat plus y j hat. In this case, we get the partial x derivative of minus x, which gives us minus 1, and the partial y derivative of y, which gives us plus 1, minus 1, plus 1 gives us 0. A more complicated example, we'll evaluate the function x squared plus 3xy squared plus y cubed I hat, 2x e to the y plus y e to the x j hat. In this case, we take the partial x derivative of the x part, which gives us 2x plus 3y plus 3y squared plus 0, and the partial y derivative of our j component, 2x e to the y plus y e to the x, which gives us 2x e to the y plus e to the x. Now, notice, I have no vector components written here. The divergence gives us a scalar function, a scalar valued function. So our final answer becomes 2x plus 3y squared plus 2x e to the y plus e to the x.